This is spanning tree. Yeah, this is CIT 1122, Module 5, Sub-Module 2, spanning tree operations. In spanning tree operations, what we're going to do is talk about how spanning tree is able to block layer 2 loops programmatically. And it's a four-step process, which is written out on this slide. Works out pretty good. Step 1, elect a root bridge. Step 2, elect the root ports. Step 3, elect the designated ports, and step 4, elect alternate blocked ports. Okay, so step 1, elect the root bridge. That seems cool. And then step 2 through 4, just label all the ports as either root or designated or blocked. Easy enough. Okay, so here's the thing. The reason it's called a spanning tree operation is the concept of a tree being getting all of its nutrients from the ground. And there's a single trunk in the tree, and everything has to ride across the trunk in order to get to all the branches. So when we elect a root bridge, it is like the trunk of the tree, and it will be the center of the communications, and all paths will have to pass through that device in order to make their way from one device to another. So for instance, in this particular diagram, you can see that there's switch 1, switch 2, switch 3. Each one of the switches is connected, and we have a physical layer 3 loop, or excuse me, layer 2 loop between the 3 switches. And we have a direct connection between switch 3 and switch 2. Downside is that link is going to be programmatically disabled or blocked because the root bridge that was elected was right over here in switch 1. So in switch 1, we've elected the root bridge. Now, the way you can elect the root bridge is as follows. Each switch has its own bridge ID value, which is based on the switch's MAC address. The switch's MAC address is then tied to the priority value, and between those two items, you get your you'll be able to elect your root bridge. Lower values are preferred. So as we look through these 3 switches, the MAC addresses of each one of the switches start with 000A, and the highest MAC address is actually switch 1. And if the priority values were exactly the same, then switch 2 would have been elected as the root bridge because it has the lowest MAC address in the space. Now, someone has gone in and changed the priority value of switch 1 to a lower number. The default priority value for any given switch is going to be 32,768 plus the VLAN number. So in this case, this is VLAN 1. So these ones all came up at 32,769. That's the default value. However, someone did change the priority on switch 1 to a lower value, 24,577, and it has to be a multiple of, I believe, 64. You can't just say, I want to go one less, 22,765. I believe the number that we can use for priority has to be divisible by 64. So keep that in mind. Anyway, the priority value has been lowered, and that makes switch 1 the root bridge. There is another method that you can use where you can just say, you know what, I want this switch to be the primary or root bridge, and it will become the root bridge. In this case, what we want to do next is identify the different types of ports. Now, the types of ports are a little bit confusing because the root ports are not actually on the root bridge. The root ports are the ports that are connected to devices, and any port that would forward traffic towards the root bridge would be identified as a root port. So the root ports are actually right here and here. Those are our root ports. The next slide actually has a really nice diagram. It shows you where those are at. Other ports that we want to identify, we can identify excuse me, let's go to another color. Designated ports, and we can say this and this are both considered designated ports. These are going to be our designated ports on the root bridge. And then the final one, this will be a designated port as well. The final port that we need to identify would be the blocked port, And we're just going to go ahead and say our blocked port is going to be right here. And a couple things about blocked ports. You would never, ever have a blocked port that's connected to the root bridge. So in this tiny little system, the blocked port, of course, will be between S2 and S3. If we take a look at this slide here, this has got everything labeled as it is, with the exception of the blocked port. They ruled mine as a designated, so our blocked port would actually be over here in this particular case. But you can see the designated ports, you can see the root ports, and it's important to remember these only because there's going to be some test questions on them, and then you should just be aware that what a root port is and what a designated port if you're going to use spanning tree protocol. Okay, all right. So keep that in mind. Here we can show you the alternate port or the blocked port, and the other one is still set as designated. And remember, if something was to happen here, right? Something was to happen here, then this would go from alternate to go to designated. And it would go ahead and turn itself on, and that would keep the system working even when there is a hardware failure. Okay? Keep that in mind. There's a couple other things to remember about spanning tree. The default spanning tree protocol has been around for a while. We're going to get some advanced types in just a minute, but the base process is a 50-second process that you need to get a switch to figure out what interfaces it should either block or forward with. So there's a couple of things that'll come up. You may have noticed when you've been in the classroom, or if you're ever working with basic Cisco equipment, that sometimes it takes a really long time for those ports to come up on a switch, and you might think to yourself, I'd really like to find out why it's taking so long for this switch to come up. And the answer is it's because spanning tree is running by default on those switches. So what first thing that happens is this, is you turn a switch on, and all of the ports are going to be in a blocking state, and they're just going to stay there for 20 seconds. Nothing's happening. The electricity is flowing, and they're aware that the interface is on, but nothing's really happening, okay? Now, on this slide, it says in that time, no BPDUs are sent. So BPDU stands for Bridge Protocol Data Unit, and a BPDU is a message that a switch will send out to really the likely target would be another switch, and it sends out these BPDUs and it says, "Hey, I'm a switch, and my bridge priority is my bridge ID is this particular value. I'd like to be the root bridge if possible in this system." So when BPDUs go out, they always leave any switch interface, and it does take 50 seconds for that to happen. So go from a blocking state into a listening state where they're listening for BPDUs to come in from other devices, and then a learning state where they're sending out their own BPDUs, and they're picking out and figuring out who's going to become the root bridge within that system. And that's the process that it takes with spanning tree. Now, this is a long process. 50 seconds is a long time. It never used to be a long time because you'd have to worry about it because you're like, PCs take like 2 minutes to boot up, so who cares if it takes 50 seconds for your networking to start? But with the new SSD drives and the new M.2 drives, much faster. PCs boot really, really quick, and then you find yourself waiting for a spanning tree. So there are some timers that go along with it, but these are the default times, and this is just a kind of a nice aside as to why those things happen. Okay, so keep that in mind. Another thing you can do with spanning tree is if you have different VLANs, you can actually offset the spanning tree root bridge onto different switches, so they won't all have to be. You wouldn't necessarily want one switch within your system to be the root bridge for all the VLANs. You might have different traffic patterns. You might have all kinds of different reasons for changing your root bridge per VLAN. So you can actually have a root bridge for like VLAN 10, that could be switch 1, and then switch 2 will be the root bridge for VLAN 20, and switch 3 would be the root bridge for VLAN 30, and you can defer traffic that way as well.